Electroplating is used to protect metals from corrosion and make articles more attractive. Copper plating is easy to set up in the laboratory. All you need is a solution of copper sulfate and a method of passing electricity through it. Two carbon electrodes attached to a power supply are immersed in the solution. Switch on, reactions begin, and a current flows. On the left, at the positive electrode, bubbles appear. This colourless gas is oxygen. At the negative electrode, there are no bubbles, but the carbon is slowly starting to change colour. It's being coated with a layer of copper metal. Copper ions in the solution are attracted to the negative electrode. They react to form copper atoms and plate the surface of the carbon. It's the copper ions that give the solution its attractive blue colour. So as they're gradually removed, what would happen to the solution? Change the electrodes to copper and different reactions occur. This time nothing appears to happen at the positive electrode on the left. There are no bubbles, so oxygen isn't being produced. But at the negative electrode, the copper is beginning to change in appearance. To find out what's happening, we first need to weigh a new set of electrodes. This is going to be the positive electrode. It has a mass of 39.60 grams. The negative electrode has a mass of 39.61 grams. They're almost the same. 2 hours later, and reweighing provides some clues about what's happened. But first the electrodes need to be rinsed and dried. The negative is now 40.92 grams. It's heavier than it was before. The positive is 38.22 grams. This electrode is now lighter. To explain these changes, imagine you can see the particles in copper sulfate solution. There are positive copper ions and negative sulfate ions. Switch on the power supply and the copper ions are attracted to the negative electrode. The sulfate ions are attracted to the positive. The copper ions gain electrons. They lose their positive charge and form a deposit of copper atoms on the metal strip. At the other electrode, the negative sulfate ions don't react in any way. Instead, copper atoms in the metal strip become positively charged ions, which dissolve into the solution. While one electrode loses weight, the other gains it. To electroplate an object with copper, a similar setup can be used. The solution is still copper sulfate. The positive electrode is copper, but the negative electrode is now the object to be plated. After a few minutes, the spoon is plated with a good coating of copper. Increase the current and see what happens. A thicker layer of copper forms, but the plating is poor. It rubs off easily. The size of the current used during electroplating is crucial.